Hello, in this modern OpenGL video we're going to be looking at lighting, and more specifically we're going to be looking at the basics of colors with your objects and with lights. We're going to have a vertex shader and a fragment shader like we've already got for an object box, essentially like the lighting, and then we're going to have one for an actual light itself, so almost like a lamp. So we'll have a lighting shader and fragment shader, which will be for the actual object, so the way it is lit naturally, and we'll just be using a simple color in this video. And in future videos we'll be looking at some really cool stuff like specular lighting, light maps, that sort of stuff, and we'll have a lamp vertex shader and fragment shader to have some sort of like light that's emitting light. For you prerequisites, make sure you've done or you've got source code from the camera tutorial. This is based on top of that. Once you've got that all sorted, another thing I want to mention is though I'm doing this on Xcode on a Mac, it doesn't matter because we aren't doing any sort of OS specific or IDE specific code, so you'll be all good to go on Windows, Linux, Visual Studio, whatever you're using, as long as it's all set up. The other thing is, though I'm using GIFW, you can apply this to SDL, SFML, or any other sort of framework that you're using. So now that we got that out of the way, the first thing we're going to do, remember I mentioned in the previous video, if I just run this application, we can scroll to change the field of view, and this is pretty cool just for testing, but we don't want that because that's not a realistic feature. So if we go to the camera header and where we have process mouse scroll right here, I'm literally going to delete the contents. I'm going to keep this method in there because you may want to actually use it later on, but for now we won't be using it. And then we also want to go down to here, get rid of this scroll callback, get rid of the function declaration here, scroll callback, and the final line got to get rid of is setting the scroll callback. So now let's run this, make sure it's all working before we proceed. Yeah, I can no longer scroll, I can still move around, so which is fantastic. So first of all, let's deal with the vertex shaders and the fragment shaders. What we're going to do is rename this to lighting, and we'll duplicate it in a moment and change what we need to. So in the lighting vertex shader, what we're going to do is get rid of the texture coordinate because we're not going to be rendering a texture in here. We'll be getting rid of that code as well. Get rid of the out texture variable. We're still using model view and matrix. We're still using this calculation. The only difference is we can get rid of this texture coordinate line because we no longer have a actual texture coordinate. And now in here, that looks all good. We can get rid of this. Color is fine. We aren't going to be using any of these. We're going to be using a uniform vector-free object color. So this is the color of the object itself. It'll be a cube in our example. And let me zoom in a bit. And we're going to do uniform vec-free, and this is simply going to be the color of the light itself. So for color, let's just get rid of all of this. I'm going to put vec4, and to calculate the lighting, all we do is light color times by object color, comma 1.0f. So obviously the alpha is fully on. And what we got left, yeah, for the lighting, vertex shader and fragment shader, very simple in this video. We've got that all sorted. What I'm going to do is duplicate these like I said. Actually, let me save these first. And what we want to do is rename them to lamp.vertex shader and lamp.fragment shader, or lamp.vs and lamp.frag. And now in the lamp.vs, what we're going to do is we're keeping this line, the position, model view matrix, and yeah, actually we aren't changing a thing, which is fantastic. So in here we have a vector for color, fine. We're not handling any object color or light color in here because this is just a lamp, not our box. We can get rid of that. And for the color, all we're going to do is set it to 1.0f. So all the vector values will be set to 1.0f. That's the red, green, blue, and alpha. So it will be fully on. If you have full red, full green, and full blue, you get white. You might have done a experiment in high school where you get all like the different colors of the rainbow on a circle, and if you spin it fast enough, it looks white. It's a pretty cool experiment, and you probably could do it at home. It's worth checking that out. Just in general, not for this video, it's just a fun thing to do. So we've got our shaders all set up. So if we go to our main.cpp file, and the first thing that we're going to be doing is, if we scroll down before our int main, what we're going to do is put a glm, let me zoom in, I do like zooming in, glm vec3 light path. So this is going to be the position of the light itself in our world, 1.0f. So this is going to be the lamp, position, 2.0f. Because the way it works is you have light emitting from a particular location, and then you would have some sort of, let's say if you load in a light bulb model, you would place that there. The light bulb itself isn't emitting light. The actual light source is just placed where the light bulb is, and it looks like the light is emitting from a light source, or what we perceive as humans as a light source. And as a result, if we move the bulb or the light source, we have to also move the object that it's essentially emitting light from. So that's just a little really brief overview of how things work in not just OpenGL, Vertex, just graphics in general. So if we just keep scrolling down till we hit the shader, because we got a couple of shaders now, we're going to duplicate this, and I'm just going to rename this to lighting shader, rename this to lamp shader. Obviously we need to update these as well to lighting, not lighting, and this will be lamp, And now for the vertices, what we're going to do is remove the texture coordinates at the end, so we only want the x, y, and z. Because remember, we've removed texture rendering, or we will be in this video. Let me see, square brackets. Square brackets are awesome. If you're a coder, the text editor or IDE you use just has to have square selection, not square brackets. I think I said square selection. It's just, this is a must in my book. Delete the cube positions, because we're only actually going to be rendering one single cube. It'll just be easy to see what is going on. And for here, we're going to change this VAO to box VAO, because we're going to have a vertex buffer object which we'll just reuse, but for the vertex array object there'll be a different one for each individual sort of shader. So, and box. So if we go to here, we just need to update this so it says box VAO. Do the same over here. So box VAO. So let's just make sure everything's all good. For the position attribute, we got 0, 3. That looks all good. And just want to make sure everything's okay. The binding of the vertex array is done. Oh, yeah, we've already done that. So the vertex attribute pointer 0, 3, that's fine. GR float, GR false. we've got to update this because we no longer have, sorry, no, put my phone on silent. We no longer have 5 pieces of information per vertex, which was X, Y, Z, and the 2 texture coordinates. We only just have X, Y, and Z now, so we need to update that. Very, very simple stuff. And we can leave that as it is, and we can remove this entire texture coordinate attribute because we're no longer using textures. What we're going to be doing is duplicate, I would say, all of this, and we'll just change what we need to do for the light vertex array object. When we're referring to like light vertex array object, we're actually referring to what the lamp is emitting from. It's sort of confusing considering this is called lighting. This is lighting of the particular box. So we can get rid of VBO because we'll just be reusing the other variable. For this, we're going to put light VAO. For this, we're going to put light VAO again. We're going to put light VAO bind vertex array. That seems all good to me. 0.3 GL float, 3 times size of the. That honestly looks all rosy, dandy, and positive. So the next thing that we're going to be doing is, yeah, that was another thing I need to update as well. So let's get rid of this entire texture stuff. What I said in the previous video was we have the projection matrix within the loop declared every single time. And that was because we're getting the field of view using get zoom. I think it might be best if we call this field of view because it's sort of, I don't know, almost confusing in a way. But because we were getting it every iteration, we was getting it because we could dynamically change the field of view using our mouse scroll, but we can't do that anymore. So as a result, we might as well just get this code, whack it here, and that's almost all good. There's a few things that we need to change in here. So what we got? First of all, what we're going to do is just change the color so we have a darker background color. So the lighting will have more of an effect. That's a-okay. What we're going to do is, I don't know how much code to remove and how much code to keep. I'm going to delete all of this code actually. So I'm going to delete everything up to active texture and just basically start fresh. So what we're going to do is use the corresponding shader when setting our sort of uniform objects, drawing the objects. So first of all, we're going to do lighting shader.use. So we're handling the lighting shader of the box itself first. Then we're going to do glint object color location. We're going to gl get uniform. We're going to get the uniform location. As usual, if you would like to know more in-depth details about exactly what we're doing, you can check out learn OpenGL.com and Open.gl, which these tutorials are based on. They got some great written guide tutorials on there, and they got images to accompany those tutorials, and it's a great way of learning on top of these videos. So in here, we're going to put lighting shader.program, and the program that we want, the uniform location that we want, is the object's color. I'm going to copy and paste this. I'm going to change this to light, change this to light color, and now what we're going to do is just, if we go down here, do gl uniform freef. For this, we are uniforming the object color location. So object color location 1.0f, 0.5f, 0.31f, These are obviously just arbitrary values that have already been determined before this video that actually work well. Obviously in your future projects when you're not following a tutorial, there will be a lot of experimentation, but that's just general with programming. Yeah, that looks all good. Change this to a 1.0f. So we got 1.0f now. And now what we're going to do is create a camera transformation like a 4x4 view matrix. So if we go glm mat for view equals camera dot get view matrix, and now we're going to get the uniform location for the model view and projection. So we're going to do gl int model location equals gl get uniform location, and in here we want to specify lighting shader. My mind just went blank then for some reason. Lighting shader dot program model, and I'm just going to duplicate this a couple of times, it'll be easier. Change this to a view, change this to a projection, and I'm going to shorten it to proj. Change this to view, change this to projection, and I'm going to pass the matrices to the shader. So now we just need to do gl uniform matrix for FV, so gl uniform matrix for float values, and in here we specify view location 1 gl underscore false glm colon value pointer, and for the pointer you just specify our 4x4 view matrix. Duplicate this, and we need to do the same for projection. So proj location. Remember, we created the projection matrix before the while loop right here, so that's where we did that. If you forgot, perhaps, because I sometimes have forgot about that, where I've done it. I'm just like, where the hell is it? Where did I do it? It's not in the loop. Now what we're going to do is draw the container using the container's vertex attributes. Simple stuff. We've covered this in previous videos. If you want to recover, if you want to go over this, feel free to check out those videos. The gl bind vertex array box VAO glm colon mat for model gl uniform there we go. Need to spell uniform first. Matrix for float value, and this is going to take the model location 1 gl underscore false, and a value pointer to the model. So gl underscore false glm colon value pointer, and in here just specify model. Somebody has messaged me on Slack. Model gl draw arrays, and we are drawing it in the form of triangles. And we're starting at the first vertex, and there are a total of 36 vertices, aka 6 per side, and the 6 sides to cube. So there we go, very simple mathematics. I believe we can just copy and paste all of this and just change what we need to, because this will save a lot of time. So for this, we aren't using a lighting shader anymore. We're using the lamp shader now. So we got the lamp shader. Also, we aren't doing the view matrix because we've already got that, so we don't need to get it again. We're not doing the object or light color location, and for the model location we can't declare this variable again, but we are going to reuse it. Need to change this to lamp shader. Ooh. That's the square root symbol. I did Alt and V. That's cool. That's Alt C. That's Alt X. Oh, that's roughly equals to. Well, this is really cool. I'm having a lot of fun now. Yeah. Let's get back to coding. And let's fix this. So copy this, paste it here, here, and here. So we got the model view and projection location. And for setting the matrices, we've got the view location, the projection location. That's all good. That looks fine. For the model, because we've already declared it, we can get rid of this right here. What I'm going to do is I'll re-put it where I need this particular code. So for model, it needs to equal, I think I accidentally deleted this piece of code, glm : mat 4, so it's 4x4 matrix. And now for the model, what we're going to do is model equals glm : translate. And for the translation, we're going to specify model, and we're going to translate it to the light pulse, like so. We're going to do model equals glm : scale, specify the model. Now we need to do what sort of scale factor, glm : vec 3. Scale it by 0.2f in every axis. The reason of scaling is because we don't want our light source, our lamp, to be the same size of our box. It's just the way we perceive the world. Generally speaking, like a bulb is smaller than most things in the room that we perceive and see. So, got that fine. The GRU inform matrix for float value, model location. That's all good. And now in here, what we're going to do is GL bind vertex array light vertex array object. We'll draw in it as triangles. That's all good. And what we're going to do is GL bind vertex array, bind it to 0 because we're no longer using it. I think I forgot this particular line of code up here as well. And now the only few things we need to do is update this. So it says box vertex array object, duplicate this so it says light vertex array object. Now we're ready to run and see our masterpiece. Hopefully there's no errors. It's all succeeded. Now let's see. Yep, this has now worked. Honestly, it doesn't look very impressive at all. We got this sort of red looking box and we got our white light source. It doesn't look like it's really emitting any light, but this is just the basics. Yeah, I'm here. Let me quit Slack. That was my business partner. Wants to discuss some business. I'd rather record this video. So yeah, let's just rerun it. It doesn't look much at the moment, but I assure you this is a nice precursor to future videos and just the future of creating really cool lighting effects. In the next video, we're going to be looking at some really cool basic lighting that will make this look a lot better. So what I want you to do as an extra task is in the code, figure out where you can change the color of where you can change the color of this particular box, because it's like a reddish color at the moment, and where you could change the color of this as well, and then try checking that out. So that's it for just basic colors in lighting within modern OpenGL. Feel free to post any questions you have in the comment section on our education platform, sonarlearning.co.uk. There'll be a link in the description to that. Plus, there'll be another link in the description to the GitHub page, which will have all the source code from every single video in this series. If you like the video, please give it a thumbs up, hit that subscribe button, and leave us a comment. And as usual, thank you for watching, and I hope you have a great day.